Hey, Daniel, I think we are a bit early by a minute. Did you get a chance to attend the Triton conference? I don't remember seeing you there, but
I got the chance to attend the conference. Overall, liked it quite a bit. I was kind of exploring using Triton, migrating Vulkan into Triton, but actually, kind of after talking with some of the engineers, kind of came to the conclusion that it wasn't the best strategy. So I started working on the Microsoft Triton shared branch and sort of writing an LLVM conversion to go from the lineage dialect to LLVM.
sorry, I was muted. Daniel, I was asking if you're based in a non-GPU based, I mean, you're interested in non-GPU based backend?
Yeah. So currently, what I'm doing right now is trying to use when I do the LLVM pass to use the ARM Neon dialect to be able to get Triton run some ARM-based systems.
Mhm. Okay, I see more folks joining. Let's give folks maybe till up to 10:03, and then we can get started. Hey, Thomas, I have started recording the meeting. I will be taking notes.
Great.
Yeah. Okay, I think we can get started. The first item was the update for H100 from OpenAI. So today Thomas is going to chat about it. Yeah, go ahead, Thomas.
Sure. So yeah, I don't have slides, but I'll mention what we've been doing recently and where we're at. So on H100, we've enabled the WGMMA by default. So now any matmul kernel will use it. We've enabled FP8 formats that are working. We're getting 1.3 petaflop out of 2 petaflop on a dense matmul on H100. We've enabled flash attention using the WGMMA and using passing the LHS operand show register, and that allows us to get about 450 teraflop on the forward pass and 260 on the backward pass. There's still optimizations that needs to be done for flash attention. We have quite a lot of performance left on the table. We have not enabled TMA by default. There are still multiple issues that are work in progress, and that's going to be one of the next big thing. And yes, I think that summarizes where we at the time. Not sure if you were expecting more details or anything.
Yeah, were there any questions from anyone or anyone wanting more details?
Did you say that warp specialization is not enabled, right?
Correct, I haven't talked about. So warp specialization is not enabled. There's some prototype that have been developed by NVIDIA team. Mm-hmm. It's not enabled by default. There is a flag that can be passed by user. It's fairly experimental at the time.
Okay, so that's the config option. That's a config option, right?
Correct. It is a
Right,
config
okay.
option. It's not going to be something that's ever going to be decided by the compiler. It will be a config option. Ideally, it would be exposed in the language in a better way, but obviously it's not a simple change in Triton language.
Okay.
I thought there was another question. Okay. Yeah, Jason, go ahead.
The float 8 numbers that you were talking about, was that, I'm sorry, I missed that. Was that gem or was that flash tension?
Gem.
Repeat that.
All right. So on flush attention, we have a version that uses FP8 for basically for two of the inputs, but for the second matmul, running it in FP8 is actually fairly tricky because we would not be able to pass the results directly from register because the FP8 format is actually, like the FP8 layout is actually significantly different than what is being returned by a WGMMA. So chaining multiple dot operations using FP8 is actually not easy, and most likely the format, the layout conversion would kill the performance. So we did some experiments there, but so far we haven't found a good way to do it.
Okay, so that was just gem performance then?
Gem performance, yeah, dance large matmul, like very square, like 8K by 8K by 8K large matmul.
Gotcha, thanks. I noticed the flash tension tutorial had F8 added, so assuming that's kind of what you're running, but it's kind of default there. Is there any plans to maybe kind of make that switchable or optional? Or
yeah, we can make it optional. I mean, the tutorials, we don't really use it for anything else than just showing off kind of the performance and capabilities of Triton.
Yeah,
could be made an option, really. Yeah.
Okay, yeah, just that's fine. We kind of did that internally too, because we're.
Oh, and feel free to send a PR if you think it's relevant.
Okay. Yeah. Okay. We probably can do that. Yeah. So, thanks. Appreciate that.
Okay, any other questions before we move on to the next topic? If not, let's move on to the update for the shared middle layer by Ian. Sorry, was there a question? Okay, maybe not. Ian, go ahead.
Hi everyone. So I gave a talk at the Triton conference about shared middle layer for Triton. And so I'm going to present today a little bit of the, I don't have a lot of time, but I'm going to try and present a little bit of what we've been doing and kind of some of the really brief overview of the technical details. So I'm going to share some slides here. Hopefully this will work. Okay, cool. All right, so this was from my talk last month. So the idea, we need to scale Triton to target all these backends. And so the one way to do this is to help try and create more of a connection to the MLIR core and create a place where folks can share code and ideas. So this is sort of the streamlined design for the NVIDIA backend for Triton today. And so what I'm envisioning is sort of this split path here where so some backends might be streamlined and just go directly to their proprietary machine IRs, and then others might pass through this shared middle layer, which would take advantage of some of the built-in MLIR dialects such as Linnell. So to spring this forward, we've created a repo where you can find this middle layer. So there's a link there. I'm not going to try and click on it because PowerPoint does not have the ability to show the result of a click. So we'll just let folks click on that on their own and take a look. we have the middle layer shared there, and it is now available as a plugin into Triton. So at the bottom there, if you go to the Triton website and you look at in their third-party plugins, or if you've pulled recently from main, you'll see that the plugin is there, and it is buildable. The directions to include it into a backend are available on the Triton shared README file in the Triton shared repo. So I have a slide on this. So the simple directions, basically you're going to set this variable, and then you're going to run a build, and then that will enable all the Triton shared components. And so you can sort of test it out with our version of Triton Opt that includes our passes. And it's intended to be used not as a standalone necessarily, but as included as part of another backend. So for example, if you are developing a backend for, let's say, some accelerator, you'd create a plugin for your accelerator, and then you'd include the files from the Triton shared inside your plugin, and then just build them together. And we have some prototype work for that for CPU backends that seems to work pretty well. So as far as the repo goes, we are really excited to have it open and public, and we'd really like to start to get contributions from the community. So everything from requests of what you'd like to see, to code contributions, to discussions around the work. The goal is to have this pass, or the set of passes, to be no fail, so that any Triton language construct correctly converts into the middle layer. We're not there yet, so anything to help us along that path is desirable. So I have a list of sort of things that we're looking at. If folks are thinking, oh, how can I contribute, or how can you, what's going to be coming in the future? So this is sort of just a PowerPoint bullet of set of bullets of kind of high level what we're looking to do. Yeah, I see a hand up.
Yeah,
so
yeah, there's a question. Yeah.
Yeah, so this sounds so this is good, because each backend can opt in and decide to use a different kind of dialect. My question is very simple. It seems common enough they should be in the Triton repository and not another in a different repository. Any plan to put in Triton directly?
There's no plan right now to put it in Triton directly. I think what I'd like to see is that if folks start to take a dependency on it and it becomes critical for multiple backends, I think we could make a case to the community to start to move this into the core. But right now, right, there is no dependencies, and so it's a tough sell to kind of have Phil and friends at OpenAI kind of maintain this day to day. So for at least until we get some more folks kind of saying, yeah, I really need this. This is really critical to my business. It's probably going to sit as external.
So maybe a follow-up question. I may have missed this. You use it in your AMD backend? Do you go through this path, or?
So my team doesn't do the AMD backend, but maybe somebody from AMD can comment. I know they've looked at it. I don't think they're currently using it though.
We do not. Yeah, we're kind of closer to the NVIDIA path. We can mostly get what we need going that way. This is interesting. We do have our our third-party backend in there, the third-party directory as well, and we're working on that. But we don't need this just yet, but we're watching it, so we'll kind of see how it evolves.
Okay, thank you.
Yeah, great. Yeah, another hand went up. So I think it was Daniel. Is that right?
Yeah, so I had a question kind of, I think I've talked to you about kind of like being able to take, because, the knowledge dialect, the memref, those are all existing LVM dialects. So I was kind of trying to use Triton shared to run it on like ARM CPUs. I do know whenever I try to compile Triton for like on an ARM platform, there are a lot of sort of like kind of like different parts of it that will fail, and I'll have to comment them out and all. I'm not quite sure if Triton will even compile on ARM without me having to make a bunch of modifications. Do you think later down the line that could be a point that would be addressed?
Are you asking about actually building on an ARM platform as opposed to targeting ARM? Sorry, I was a little confused as to exactly what you were asking about.
I was talking about building, but I don't think it should be too large of an issue, but it's just a point that I guess would be nice is if it could compile on ARM, but it wouldn't need to necessarily to target it.
Right, that's right. So yeah, I don't know. That would be a good question for the community about maintaining build that works on ARM.
All right, sounds
good.
good.
Phil's not here, so we can. I might want to bring that up on the GitHub issues for the Triton core. Okay.
Yeah, and Daniel, if it's not addressed, we can also bring it up in the next meeting, next community meetup.
All right, thank you.
Cool. All right, so I'm gonna just go real quick. Well, I don't know about real quick, but I'll go to a little bit of overview of kind of what's in the shared plugin, so folks can at least have a sort of top level view of what we're doing. So right now we consist of 3 analysis passes and or analysis features, and then a couple of conversion passes. So so we have this pointer use and mask analysis, and then our conversion to different dialects. So I'm going to go through. Let's see. I'm looking ahead of my slides to kind of figure out how to cover this quickly. So the pointer analysis and mask analysis and use analysis work together to try and convert arrays of pointers into pointers of arrays. So basically, we're trying to convert from a SIMT model to directly into the SIMD model, which is more amenable to the middle sort of lineage style. It doesn't have to be lineage, but lineage style sort of cogen or representation MLIR. There's some stuff here. I don't need to go over too much. So if you're curious about what's the pointer analysis, it's actually a forward pass through the code, and folks can take a look and learn more about it. But if you want to kind of get a feel for it, a backwards look at the code is sort of interesting, I think. So this is not the algorithm we use in practice, but it is in semantically equivalent. So so given a memory reference here, does the animation not work? We know the length. There's one animation missing, but I think folks can follow along. So we have this load here. We know we're going to load. There's a laser pointer. We know we're going to load 1,024 elements, and so we start to work back. We can work backwards from that and say, oh, there's an add, and we can see that it's a splat of this value, which is passed in. So the base of our load's going to be this argument, and then the other half of the add is pointing at this other add, and then that's coming from a splat of this multiply, and then that's coming from the program ID, and then we go to the other branch of the add. So real basic walking of the IR, right? And then we can see, okay, this actually, once we get to here, we're actually just verifying that this is what we expect. It's a solid range from 0 to 1024, so we know that we are done with our computation. And right now, today, we're asserting this. So you can imagine, to handle the more general case of like, oh, we need anything, we need to be able to detect when it's not a contiguous load and then generate the sequence of load stores to kind of do the scatter gather operations. Then the last slide I have here is just to demonstrate some of the lineage conversion. So there should be an animation here, but it's missing. So cool. I'm glad I checked through my slides before I presented today. But basically here, you have this code here, this from the body of the layer norm kernel, and then it's going to expand into this sequence of instructions. And you can see in here, I know it's really small probably for folks, but feel free to zoom in. You can look at some of the lineage operations that get created from this. So I'm not going to walk through this today. It's a little bit much for one slide. So yeah, so that's the overview, right? It's analysis and conversion. It's available for folks. We're pretty confident with what's in there to handle sort of all the Triton that appears in the tutorial. Well, the tutorials have expanded greatly since we started this project. We believe it handles sort of like the first 6 basic tutorials, and then we're going to continue to add features in this to try to generalize it to support everything in Triton over time. Okay, yeah, thanks for your time. I haven't been watching the chat. So Shama, is there anything interesting in there? Should I?
I think there were ARM related. There was an ARM related discussion, but Shintaro does have a question.
Good.
Shintaro,
I'm glad that discussion continued. That's fantastic. Cool. All right. I think I see a hand up.
Yeah, thanks. I think like a pointer analysis is very useful. So is it like, I mean, how to say, converting the traditional, tensor pointers to the sort of tensor pointer, or it does something different?
So I think maybe you're talking about the tensor pointer abstraction that's in Triton.
Yes.
Yeah, so we started this work before that was a thing. So we kind of just bypassed it completely. So we're going to go right from the array of pointers to directly to a memref. So we could from Triton pointer, which is like this replicated thing, to a memref, which is the SIMD style. We also handle converting the Triton tensor pointers into the memrefs directly, because we don't need the pointer analysis to do that, because those things are already easily convertible to SIMD. So I know, yeah, we've talked to some folks from Meta that are interested in kind of building a middle layer there. So we pass from the array of pointers to Triton tensor pointer when it's legal, and then to the raw memrefs, and that certainly is something that we should be able to support. And so folks are interested in adding something like that, we'd be happy to take that, I think, into the tree.
I mean, from the community's perspective, I think, like, I mean, it is very generic and it is useful.
Yeah, agreed.
And maybe, like, I mean, we can even, like, I mean, introduce it inside the Voices Triton side.
Yeah, I think that could work.
Thanks.
Any other questions for Ian? Okay, let's move
Cool.
on to the.
Thanks again.
Thanks, Ian. Yeah, let's move on to the Intel update.
Today I will let Jianhui to introduce to update the Intel status on the Intel GPU backend. Okay. Jianhui, please.
All right, thanks. Thanks, Zach. So on the update, so we have rebased to the latest Triton. And recently Triton had an upgrade on LVM, so that caused a building failure, and we fixed that also. So basically, currently Triton on Intel GPU is functioning for all non-GM operations, and then we are able to run torch induct benchmarks. Like supporting all those like PyTorch models. Then we also conduct a bunch of performance analysis, use that torch inductor based micro benchmark. So we construct a bunch of micro benchmark, and then inside the torch inductor we make that the targeting Triton, so that we can do the performance analysis. For the GM, lowering is on progress. So I have one more slides to cover all the challenges we have for lowering the Triton dot to Intel hardware. Meanwhile, we also look at the generalized MMA layout. Also, we are looking at the CPU enabling. So that's we don't have we don't have a really something running for the CPU yet, but we are exploring different solutions and to see which one can meet the needs for Triton. Yeah, I have some questions to the community also. It's like, what is the best way? So on the gem roaring, so this is the most actively developed item within Intel. So we want to lower that Triton dot to Intel GPU. So there are a couple of issues, when we try to map Triton programming model to Intel GPU. So the first one is that the Intel GPU, like we're talking about the data center GPU, XE GPU, discrete GPU, and then that one has a 2D block loader. So in order to feed this DPass engine to be efficient, we have to use that instruction, and that instruction does a synchronous load. It's not async, it's just synchronous load, but it has to be set up incorrectly in such a way that load a small 2D tile. That does not match the tensor pointer programming model, or the initial like the current default programming model, because that one, within that, so like each individual address within that tile, like each individual address could be different. Basically, Triton allow user to do arithmetic on those pointers. So we really look forward to map the block point and program model to 2D block load. So that is the perfect match to hardware.
There's a question. Yeah. Go ahead,
Yes.
Thomas.
Right. I was wondering, are you sure the best mapping is to use tensor of pointers? It feels it could be just a layout. It could be just a load with a given layout that you would lower to this block, especially if each thread would have its own pointer.
So so the problem is that our hardware is not really working at the per thread or per work item level. So it is work at a slightly bigger. You have to give it's a kind of SIMD programming model. You need to specify, say this is like a block.
Right, but what if
we could do is that we can use the I don't say it's the hardware that's completely cannot like use. We could just do the regular load, do all this like tensor layout thing. Then each individual thread, we can control each individual thread loading also. We have that regular load, so each load has its own offset. So in that sense, we can load it. So it can map to regular load and feed it to the depass instruction. It's just the regular load is not as that performant.
Right. No, I mean, obviously you want to use whatever is fastest on your hardware. I'm just wondering if it could just be an optimization that for some tensor layouts, you know that you can do this optimized lowering using those block pointer, those block loads. It's like just intuitively, like it feels like it should work. You should be able to have a separate pass in the load lowering that would take advantage of that based on the layout of your tensor.
Thomas, you mean we could add another layout and do some layout conversion or do some optimization passes to map the tensor pointer to the blocker pointer or to feed into 2D load, right?
Right. So I don't know if it would map to either a blocked layout or if it's a different layout that would work the best for your tensor core and your block load. Then most likely that's a layout you want to add and you want to start propagating it. But to me, it doesn't feel like.
So, yeah, Thomas. In order to use this 2D block loader, we need like for each individual, how to say, each individual like a WOP level, or in our term like a subgroup level. We need to know the basically that subgroup level. We need to load a small block, and then we need to know the stride, because the second row we need to load it, and also we need to set up such a way knows the boundary of the input matrix shape, because it could go beyond the input matrix shape. Those we find challenging given the current programming model. So we have to fall back to the regular load.
Okay, that's interesting. I mean, I don't want to drag the discussion too much.
Yeah,
talk about it offline, but
yeah, but
Thomas. Yeah, Jianhui, Thomas. Yeah, we will have some. I think we could book a dedicated meeting to since I think Jianhui we need to generalize the MMA layout, right? So I think we need to introduce some hardware specific features and introduce the layout and introduce the 2D block, and then we have some deep dive there, right? So Thomas, I think we will book a meeting with you and Phil, and we have more discussion. Yeah, for the the hardware features.
Yeah, awesome. Yeah. So the second bullet is about it's kind of a different recipe we have to follow to get to the best performance. Right now, I think the Triton pipeline is set up in such a way so that we collaboratively. I mean, it's really talk about before this GH100. It's more like A100. We collaboratively load to register, and then go to share local memory and then load back as MMA layout. For us, we don't go to share local memory. We just directly load to registers, and we don't do. But we do need to do prefetch, and that prefetch is kind of cooperate prefetch. Each WAP or subgroup is doing its own prefetch, but those cooperatively prefetch to the cache. The cache is shared to the work group counterpart to the thread proc. So we found existing Triton passes won't really help XGPU to get the best performance. We can use it to get fairly good functionality, but we need a specific passes for XeGPU. So those we need to apply to the Triton GPU dialect. So that's the second one. The third one is about that the VC computation mode. So since I mentioned that the hardware is designed in such a way, so it's underneath it's a SIMD kind of hardware, and so on top of that we support both like a SIMT programming and also SIMD programming. In SIMT program, it's matching the current Triton does, but the SIMD programming we call the vector compute mode. That VC mode give us a faster access to the performance. So meaning that at a certain point of time, that path actually is we don't have to go through the other software layers to get access to the hardware. But that path gives us a direct control to the hardware. So we're developing both mode. But in order to work with to get both mode really work, and then we are looking at an option is that instead of lowering to the thread level directly, we would like to have a gradual lowering. So lower this Triton GPU dialect first to the WAP level or to the subgroup level, so that we can further map to so that we can control at that point mapping to SIMT or VC computer mode. And that is potential integration we are looking at. And the last bullet is about there's a more optimization coming for this hardware, how to maximize this 2D load efficiency, how to use name the barrier, and also how to handle some corner cases. We have a on parallel to this Triton project, we have a project on the core MR side we developed called XG tile. So that tile actually handles larger tile than that the raw hardware instruction, and that will hide lots of hardware specific optimizations. So we think could potentially reuse that tile dialect. So those are things that our team is looking at right now. So hopefully this quarter we will be able to functionally enable the GM, and then further look at the performance items.
There's a question on chat by Daniel. Daniel, do you want to phrase it?
Yeah, I was just gonna ask if like because I know that XPU is considered like the repo is one like code base. Would this create two different code bases, or would it be the same code base just with like different flags, or?
The tile dialect, the XC tile dialect, XC GPU dialect will be living in either like in the IMAX. So we have a extension for MRR, so we'll leave it over there. And the Intel XPU backend for Triton will just like take those dialect and then build it into the backend.
Okay, sounds good. Thank you.
And then Karen, you had some comment also about the pipelines.
Hello?
Yes, we can hear you.
Yeah, maybe Li Xing can help me address my concerns. I remember that I once reviewed AMD's code and their pipeline actually used registers. At least have the capability to use registers for pipelining, like double buffering we do traditionally, instead of copying it on shared memory. But I couldn't find their repo for now.
Yeah, okay. Those codes could be really helpful. We haven't reached that software pipeline stage yet. Yeah, at a certain point we would like to try that out. So, but here it's just not talk about the software pipelining. We just do like a more base optimization flow. We do not won't go to share local memory. We just do direct load to register, but before we load it, we do prefetch.
When you see prefetching, is it like a prefetch instruction on hardware?
That's correct. Prefetch to we have a prefetch to hardware to cache.
Mm-hmm.
So
I was also trying to figure out how the shared memory prefetching instruction works, but I think I exchanged comments with Thomas. We are not able to figure it out.
I'm not sure. We have prefetch to share local memory stuff. It's more like a media specific. Or
so NVIDIA also has the prefetch instruction. Maybe we can think about it together, like figuring out a more common or uniform way to use those instructions.
I mean, on current, you mean on the Triton side, we could generalize the prefetch optimization or prefetch feature. For example, prefetch to the cache, prefetch to the shared local memory, right?
Yeah, just one draft idea.
Yeah, makes sense.
Yeah, we would love to, like look at how to make those. We will first experiment on that XPU backend side, do whatever we takes makes sense. But meanwhile, if like other team in the community look at the similar thing, yeah, let's sync.
Sounds good.
Yeah, were there any other questions?
So actually, I prepare a bunch of questions. I saw the field of come here, and so there's a bunch of like a timeline, and when you guys will do this Triton GPU generalization. Yeah, so maybe let's just go through this. Hopefully, Phil get time to look into this recorded video. So, but first of all, you know, like we have a challenge that you know, like the Triton keep moving so fast. Our XPU backend will get some unexpected like a build area or something. So then once that happens, actually we need extra time to fix it, and usually we like there's a usually that those kind of regression usually is quite big, so it takes a while for us to fix. That's fine for us to like do it as a development period, but we get a little bit nervous when we talk about the release because we don't know that how many timeline you would give us to fix those things. You know, like for example, if you say, okay, like the PyTorch guys want you to release tomorrow, and then you did a test, and then the night we found that our backend does not work. So we kind of need to talk about those things and then figure out a time period so that like a backend can have some time to stabilize. I think it is a common need for all these backends also.
Yeah,
Yeah,
Thomas, do you want to comment on that?
Yeah, I don't have a clear timeline to share. Yeah, no, sorry, I don't have a super clear timeline to share at the time. Something we'll have to discuss to feel, but I don't think he even has a super clear timeline at the...
Okay. Yeah, also other than timeline, I mean the time period, like do you have like roughly like the sense like how when basically when you set up a goal to release, and how many time you would allow the like a backend guys to catch up, you know, then we release together.
Yeah, I don't have experience with the release process. Yeah, I don't.
So, yeah, Jen Hui, is there a recommendation you can make, or some kind of looking back timeline in terms of how long you would require, which would then align with when the build process will start, so that you can make that recommendation to Phil and the OpenAI team, and then they can adjust.
Yeah, we can look at our history and then make a proposal. Yeah, I think that will make us like a more less concerned. Okay. The second item is the CPU backend. I can has a presentation last time talk about like how it could be addressed technically. Other than that route, internally we also look at another route. We just we have an OpenCL runtime on CPU that can also take the SPIRV, just run it. I don't know, maybe like some other runtime, like Vulkan runtime. What does that do? So like SPIRV is pretty like a widely accepted format. We could just use that. But you know, that also depends on how the SPIRV roaring, like the performance. Like the performance side, basically we have less control. But if we just look at for okay-ish performance, I think it will be a good way to go. And yeah, that's and the other is that what is a timeline, and I just want to also get your opinion on these things.
I think the Triton GPU generalization, we will probably have to bring it up in the next meetup when Phil is there. He may have some thoughts around it.
All right.
Yeah. For
Yeah,
the
how
CPU
about the
backend,
CPU? Yes.
yeah. Does anyone have any comments?
Yeah, at least on our side, we don't have a concrete plan for a CPU backend. But most likely, it would not be a OpenCL kind of solution. Like I think it would be more emitting directly vector. Although since there's no plans, I don't want to really, talk about that too much. But yeah, it's not something that is in the near future, at least from what I can see.
Oh, okay. So yeah, so our focus is really on the GPU also, but I yeah. So I heard from Icon that it was raised as a request, so for us to look into this. But we would happy to look at this as well, given that Intel's interests on CPU.
That'd be cool for sure. But at least on the OpenAI side, this is not part of the short-term plans.
Yeah, I think one thing I would add, like timelines or technical requirements aside, you mentioned, is this performance based or functionality based, or I think
Yes.
kind of we have to decide, which one we're going to target with this if we're going to do a CPU backend. Because I think we're going to make different design decisions based on whether we're trying to get best possible performance on multiple CPUs on one CPU or just get something to help with validation.
Yeah.
Right. Those
exactly.
are very different design requirements. Yeah.
Exactly. Yeah, we would love to get those requirements. Like in order to access the debug, then we just enable it and then as wide platform as possible. If it's just performance, then we enable on software update, for example, use those like latest hardware instruction. And each vendor maybe also want to enable their own like hardware matrix instruction, and we need to figure out a way to mapping those, like a common way for each vendor to mapping to their hardware.
So Nate has a comment. Nate, do you want to ask your question?
I was just going to ask Ian, don't we have sort of a functional only CPU backend for Triton shared? I don't know if the status, if we're still developing that, but it's something we showed at the conference.
So what we have now, it's just code gen only, and it just uses some built-in like MLIR passes to lower from Lineage to LLVM to run on a host processor. So it doesn't really solve some of the larger issues about how do we launch it, what does the runtime look like, how do you generate code for all Triton, so it's just the thing that converts to shared, and how do you need to generate good performance, what do you do with matrix multiplications, with vector operations, all those things. So those are all like high level questions that need to be answered, I think, before we push on a deep technical solution.
Are these the LLVM passes, is this already part of the main Triton branch, or is it something internal, or?
So I think I can share some. It's basically what I would say. It's like an example of how the way it was developed is an example of how you could use Lineage to target a CPU. So like you can just take some built-in MLIR passes and pass them into MLIR opt and generate code that can run. So I can share that with the community, I think, but I need to get some buy-in from my management before I do that. But I will share that if I can. It's nothing super relevatory, but I think it makes a good example of what can be done.
Yeah, because I mean, I think that, just having a bit of a framework to set up, because I'm still sort of working that, LVM pass is more just syntax. I guess it's not that difficult, but I did want to try, accelerating, being able to use like ARM Neon to accelerate some matrix multiplication, like you said.
Mm-hmm.
So if that could be provided, that would definitely help out a lot.
Yeah, thanks, Ian.
All right.
Yeah, Jen, any other comments or questions you had?
So the last one is, are there any like a micro benchmark effort on the Triton side, so that we just run that benchmark in the Triton? Are you guys working on those things?
At what level you want to benchmark?
Sorry, what?
At which level you want to benchmark? Is it individual operations?
No, like a typical use case, right? Like flash attention or some sparse attention, those things. Right now we kind of hook up with the PyTorch and then run over there, and going through Triton torch inductor. I was just wondering whether
flash attention is also already included in the Triton repository, I think.
Yeah.
And also we have block sparse.
So what about like the micro benchmark you run and then you get the performance report?
You do get performance report.
Okay. So it could be just use, so that is we could run that individual example.
Yes,
I guess.
but we don't have other operations. I thought you're thinking about a very general micro benchmark that includes operations such as reduce and scan and whatever else.
There's some basic. So there's Matmore, flash attention. Actually, we added some reduction benchmarking that runs reduce in a loop with some element-wise. It won't run out of the box because it relies on knowing the GPU and knowing what is the reference performance. It's mostly there for regression testing. But if you look in like the performance tests, it could probably be applied to any other target without a lot of work.
Okay. Currently, I'm aware that the Triton has added the inductor, Hugging Face, team, torch bench, the 3 benchmark suites to the Triton for the performance measurement. So it is an end-to-end benchmark, right? So, but in that side, we're trying to extract the fused atom operations and then produce the Triton kernel, and then take these all produced Triton kernels at the macro benchmark to measure the performance. And because all these Triton kernels, right, so it are produced from the real workload. So Thomas, do you think it does make sense to add these macro benchmarks to the Triton report to measure the Triton PR performance as a performance measurement to measure the PR?
I mean, yeah, to prevent regressions, I think you definitely want micro benchmarks. I mean, obviously, you also want bigger benchmarks. Micro benchmarks are very convenient to make sure you're not regressing performance on those critical ops.
Mm-hmm. Okay.
Which, I mean, yeah, I don't know if you'd have to go in repo, but I think you can extend easily to what's existing along with in the downstream repo you have. I mean, we can see if like it can be improved to make it easier to generalize, but I think it should be very similar.
Mm-hmm.
Yeah, sounds good. So the last item is that that gradual rolling thing. So we were thinking about adding like subgroup level before we just go directly to the thread level. Is something you would think about this, or I mean, or we is it something like a common need, or it's just like Intel guys need to do it? Like this even something like you guys think about, like or you say you know.
I've never seen it coming up, but I do wonder, yeah, what's the exact motivation? Is it just to be able to vectorize those uniform operations so that you can run them as vector, even though, yeah, is that the main motivation, or is there more behind
So
it?
it's not. It's more than that. It's not. It's basically the GM, right? So like like if we our current abstraction, actually, if we go map into the GM, our currently at the SIMT level, we have some abstraction more like a WMMA. It's kind of a join the matrix. Like you have to go using the load so that you get the register and then use feed into the path. But if we go to the a vector level, like warp level, so we just feed it into entire box block. Then
but then you wouldn't lower more from there, right? So it's basically you would pick either you go all the way to like your vector backend, and then you would stay at the warp level, or you would go to the thread level. But it's not like you would go to the warp level then to the thread level.
So, yeah, we don't. So the fancy thing could mix, but we really want to just either go SIMT level or go to the block level. Yeah, but in order to get to this block level, we want to have like a warp level abstract, like a stage.
But it sounds more like you want two kind of different backends or two like versions of your lowering from Triton GPU to LLVM, rather than, I feel like stacking them doesn't make a lot of sense. But obviously, I don't know the details.
So it's more like so underneath there's a two paths basically. So we try to unify them at a certain layer, and then you know, one path sometimes could give best performance for the time being. But we don't want to just rely on one path and then whatever. We still want to match up with the SIMT level, because that seems like everybody goes there. So that's, yeah.
I mean, if you have a different path, it makes sense to potentially enable it. But I would think the right common layer is going to be the Triton GPU, and trying to first go to vectors and to CMT is not going to be easy, and would probably not buy a lot. That's my gut feeling.
Okay. That's good. I think I got most of the question answered. And for some question, maybe we don't have answer, but I at least got, yeah, the feedback.
Yeah, and Jianhui, feel free to raise any of the questions in the next meetup as well if you want more information.
Sure.
Okay, are there any other comments or questions overall? Okay, if not, thank you everyone. Thank you also to the speakers. Bye.
Thank
Thanks
you.
for organizing.
Bye.
Thank you. Bye.